Hey, field trip, let's go. Alright, so your maths teacher is just so generous and they hired a school bus for a day trip to go, I don't know, count some trees or something a bit more fun than that. Oh, wait, but you guys had to pay for it. It was shared equally, right? So the cost of hiring the bus was shared equally. But unfortunately, at the last moment, three of your friends decided they didn't want to come for whatever reason. As a result, the cost for you increased by $1.50. All right, and our task is to find out how many students went on the trip. So the only information, or the only concrete information we're given, is the cost, right? The cost of hiring the bus, that it was shared equally. 3 students then pulled out, and there was a cost increase per student. Right. So I'm going to do it a little bit differently to the mark scheme because I feel like I didn't understand the mark scheme. That's mostly why. So let's introduce some variables just so we can keep track of things a bit more easily. So let's let x equal number of students initially going. Right now I use the word initially because, right, we could have defined it as the number of students actually going. So at the end, we'll just need to subtract 3 from this number to work out the number of the students that finally went. Let's let y equal the cost per student. Initially. All right, so with those variables, we can construct some equations. So let's think initially, if it cost $560 and it was shared evenly between the number of students going, it would cost the initial amount, right? So $560 divided by the number of students will equal the cost per student. For example, if there were 10 students, the cost per student would be $5, not $5, $56. Not that cheap, sorry. $56. But of course, we don't know the number of students yet. So that's one equation. But now let's think how we could adjust this when 3 students don't come, the cost increases per student, right? But the cost to hire the bus stays the same. However, instead of shared between x students, it's 3 less. So x minus 3, right? So instead of 10 students, it's now 7 students. And instead of the cost being y dollars like it was before, we will need to add $1.50 for the cost per student. Great. So here we have 2 equations. Right, one's the like sort of initial cost and initial students, and then the second is after 3 students back off, we increase by $1.50. Now we can, since we have 2 equations and 2 unknowns, we can solve. So what I'll do is I will use substitution. So I will substitute in 560 divided by x, which equals y, in for y in our second equation. Right, so that'll leave our equation in terms of x. So let's do that now. So 1, so this is equation 1, this is equation 2. So substitute 1 into 2. So we get 560 over x minus 3 equals y, where y is 560 divided by x plus 1.5. Great. And now our task from here is to simplify this to a quadratic equation, solve for x, and then we can then subtract 3 from that, right, to get the number of students who went. Great, so we have some fractions here. So on the right hand side, I'm gonna write 1.5 as 1.5x divided by x, which then just lets me combine those terms, right? Because I haven't changed 1.5, that's still 1.5, but I can, it's like cross multiplying essentially. So now we get 560 plus 1.5x all over x. Now we can multiply the numerators on both sides by the denominators of the opposite side. So what I mean by that is 560 will be multiplied by x, and then 560 plus 1.5x multiplied by x minus 3. So what this does is it eliminates the denominator. So we're left with 560x equals 560 plus 1.5x, being careful to use brackets here, all times x minus 3. Right, so just to clarify, we multiplied across that way and across that way. Now we can expand, simplify group-like terms. So let's expand the right-hand side. That'll be 560x minus menu, run maths, 560 times negative 3, 1680, plus 1.5x squared minus 4.5x. Great. I notice the 560x terms cancel out. (1.5x squared minus 4.5x minus 1680. Now when we get to here, we have a quadratic. We've identified the a, b, and c term, so we can use our calculator, menu, equation, polynomial, degree 2. So a is 1.5, b is negative 4.5, c is negative 1680. We hit solve, F1, and we get x is 35, or x is negative 32. So, I mean, the number of students can't be a negative number, so we can disregard that solution. And remember, x we defined as number of students initially going. So therefore, number of students who finally went is 35 minus the 3 that couldn't make it gives us 32. Woo! All right, let's recap this one. So we introduced two variables, x and y, to help us use the information from the problem, and we made two equations. We then used substitution to combine them into one equation. We then did some sort of cross-multiplying, getting rid of the denominators, and ended up with a quadratic equation, which is a very good place to be. And we just solved it. So solve on GDC. In this case, that's totally fine, right? We don't need to show evidence of factorizing or completing the square or anything. We found out what x was, and then we related it back to the problem of the number of students who finally went. So we're done. Good job.